If you go to most water utility shops, they'll have what they call the boneyard or the scrap pile, and in that scrap pile will be some water distribution valves. Those valves failed. They either wouldn't close or wouldn't open or had some sort of problem. They were leaking, and your typical water utility is going to go out with the backhoe and a crew of men. They're going to cut that valve out of the system, put in a new valve, and the old valve goes on the scrap iron pile. And that's the end of the story for most folks. What I've tried to do over the past year is a program I call Valve Autopsy. When a person dies, they usually go in and try to find out why they died. In the case of water valves, when they die or fail, it just ends up on a scrap iron pile. So I've asked some different water utilities to save old valves for me. And in one case, a utility gave me two valves that were identical, 4-inch valves that were put in 1954. Water valves are a little bit unique in the valve market that they have to have the date of manufacture cast into the body. So it's helpful to know when you dig up that valve by looking at the date, how long did the valve last? And in these cases, in the case of these two valves, the valves had 1954 date code, so they're actually the same age as me. So I could kind of identify with that. These valves had obviously been left in the closed position for many years. And tuberculation, which has a very lengthy definition, but basically tuberculation is when iron oxides and deposits cling to the internal parts of valves, causing what appears to be rust. It's really not rust, but it's certainly a coating that when it's on the various components, especially in metal-seated double disc valves, will virtually cause the valve to be inoperable. And that's exactly the case in these two valves. I took the valves apart. Initially, and one of the most important things about valve autopsy is to study the valve throughout the process. When I looked at these two valves, the valve operating nut turned freely. Now most people would look at that and say, oh, well, the stem in the valve was broken. That's a very common misconception people have. Upon taking the valves apart, the stem in both valves were in fine condition. The gate itself actually broke because as this water utility tried to open the valves, they just continued to apply force until something broke. And it was actually the gate in the valve that broke. I actually went back and put a temporary patch on the gate and reconnected the valve stem to see if there was any way that I could get the valves to break loose. And unfortunately, the tuberculation was so severe. And as you can see in one of these photographs, the entire inside of the body is just one huge mass which appears to be rust, but again, it's the internal components of the valve coated with tuberculation. When I picked it up from the customer, we could see that the rubber coating on the gate had been compromised. The customer said, well, something must have come down through the water line and actually hit the coating and then damaged it. But in looking at the coating, it was actually bubbled out almost like a balloon. So again, looking through all the different characteristics of the valve before I disassembled it, the valve still operated fine. It just wouldn't close off properly. After taking the valve apart and looking at that resilient seated gate, it's a rubber coated ductile iron or cast iron gate inside the valve. I could see that the coating around the bottom of the gate where the stem hole is cast into the gate was actually beginning to delaminate. And my theory was, in talking to an engineer at the company that manufactured the valve, he seemed to think that the theory had some merit, that the valve had not been closed completely, and that the water flow behind the gate was actually delaminating this rubber coating on the gate. He also suggested, in looking at the photographs, that the chemicals that the water plant was putting in the water may have caused some corrosion to start, and then caused that rubber coating on the gate to debond. So what happened is the water pressure got behind the coating, and it was seeking the easiest place to escape. And that's when this bubble began to occur downstream, and eventually there was enough water pressure in the bubble that it actually burst. And that's what caused that bubble effect on the rubber coating. If folks in the water distribution industry would collectively pool their information, we could then help many, many more people. The more information we have, the better. I'll be more than happy to share some of the findings that I've had with any water utility that contacts me, and conversely, I would love to hear from them. There's probably someone out there like me that's looking at these valves and asking some questions and doing a little research into what caused the valves to fail. The more information that we could gather together and then share with other folks in the water industry, the better off we'll all be.